All right, in order to estimate pi to the 450th power, we're going to set up the equation here that we need to. And that equation is k is equal to pi to the 450th power. Then what we're going to do is we're going to take log of both sides. And we have a little rule that says I can move this 450 out in front. So then I got log of k is equal to 450 times log of pi. And then this one, again, don't estimate yet, but you're going to use a calculator here in order to determine what that would be. All right, and what we'll get is 223.7174427, and just keeps on going. All right, then we're going to put a base of 10 on both sides here as we bring it on. This is canceling. Let's finish it off here. So that means the k value itself is 10 to the 223.7174427. And then we're going to move this around. So we're going to leave the decimal point that's there. All right, then we have to evaluate this again using a calculator here. When you use a calculator, you get 5.2173. And then that is the leftovers right there. So 5.2173 times 10 to the 223rd power. Next problem that we have is this one right here. This one you don't need it. It's just like the previous problem, but you don't need to do it right away. I mean, all the way through. Because whenever you look at something in scientific notation, let's look at a quick example here. Whenever you look at this here, let's say this is 58 here. Now the number of digits that you have is really, in a sense, is if you start taking this out, you're going to go 1, 2, 3, you're going to go out 58 times, but you have this little extra one. So really the number of digits this number has really is 59 digits because it has this little extra one right there. So what we have to do is just figure out what is the exponent that is left over. So let's try the first one here. So this is 231 to the 544th power. Again, log of both sides. And I'm going to skip a few steps here just to make sure we're okay. And then when you do that, the log of k value that you get is 1,558 point, and then there's going to be all that afterwards. I don't really care about that because eventually, in a sense, what you really get is you get a k value that's 10 to the with change. So really, in a sense, what you have is you have 1,259 digits because of the extra one that is going to come in as you put this into scientific notation. The other side is going to be 544, 231. Okay, log of that number. Skipping a few little steps here, which I think you guys know to do. And then what we do is we get this to be 631 with change. I don't even need to go that far. I mean, I don't need to go any further because then this number has 632 digits as I finally get into scientific notation. So which one is larger? This is larger. And the reason for it is because it has 1,259 digits. This one only has 632 digits. All right, now we come to the half-life problems. The half-life problems, it is a equation in the textbook here. The textbook equation is like this. And if you can get into that, that's cool. And then the other equation that you need, the formula itself for half-life is it's a negative ln of 2 over the k value. Well, we use this equation to figure what the k value is. Once we do that, we plug it into that equation. So let's go for it here. So first equation's first, ln of, now a of t. So the amount left after 12 hours 22, we started with 45, and we're going to go k times 12 because we do it in terms of hours. This one you can do on a calculator if you like here, but eventually you get a k value of ln of 22 over 45 over 12. We're going to use that to plug into h. So h is the negative of ln of 2 over ln of 22 over 45, which is over 12. And you got to plug that into a calculator, and you should get a value of 11.6 hours. There's your answer, which is a little different than the 14.2. All right, and the other one here, again, another half-life formula. Don't forget to use the formula as we need them. So we're going to go ln of the substance that we have over the substance that we started with already, and then k times the number of hours it has been decaying, which is 15 in this case. The k value is ln of 3.6 over 11.3 over 15. And then for the half-life formula, we're going to plug it into this, ln of 2 over ln, and again, this, you need a calculator for this. Just plug that into the calculator. I know it looks pretty bad at first. All right, when you do that, you should come up with the answer for it. And let me calculate that as well. All right, and plug it into the calculator here. I got an answer of a little bit over 9 hours, so 9.09 hours. So around to 1 decimal place is needed, so it'll be 9.1 hours. All right, hopefully that helps.